All right, so we're talking about sine, cosine, and tangent, and they're twins. Sine goes with cosecant, and cosine goes with secant, and tangent goes with cotangent. So how do they work? Well, sine is opposite over hypotenuse. You knew that. Cosine is ka, adjacent over hypotenuse. And tangent is toa, opposite over adjacent. So if I were to sum it up, it's so ka toa. All of these sister ones, or twin ones, or whatever you want to call it, are just a flip. So cosecant is a flip. So if I was going to start writing SOHCAHTOA for this, it would be cho. It's going to have more of a Chinese kind of a feel. And this one, you flip it. Sha. And the last one is cow. Choshakao. That for some reason hasn't caught on like SOHCAHTOA has, but it is accurate. And you don't really need to memorize that. But what you need to memorize is that which one goes with which one, cosecant goes to sine, and that it's just a flip. It's just a reciprocal relationship. All right. So now, let's make sure that you understand where you'd use something like that. Let's say that I put in a couple of sides. Let's say I give you two of the sides here being... Do you agree that 3, 4, 5 is a common right triangle? Okay. And could this be a 30, 60, 90 triangle if I label the sides 3, 4, 5? Do you know that rule for the 3, 4, 5s? Sorry, the 30, 60, 90s? That this side and this side are double each other? Remember that? So this obviously can't work for that. Okay. So it must not be a 30-degree angle right there. So if this is a 3, 4, 5. How many degrees is that angle? Could I figure it out using trig? Yes. What you do is you say, okay, let's say I want to do sine. I can do sine of this angle. Sine of this angle, if you don't know the angle, you put theta. Equals sine is opposite over hypotenuse, 3 over 5. Did I do that right? I think I did. Okay. So then, how do I fix this? How do I get the theta alone? There is not a button that you just press that solves this problem. But here, the way I want you to think of it is this. Sine of theta equals, dang, I already forgot, 3/5. Then, how do I get the sine out of here so I know what theta is? Think of it that way. What do you think undoes sine? It's sort of like dividing by sine. It's sort of like, what did you say? Inverse. Yes. To get rid of a sine, you use inverse sine. And so if I wanted to do that, I'm going to move this 3/5 over. I'm just, same problem, I'm just moving it over so it's easier to see. If I go like this, inverse sine of this side, I can do that to both sides. Inverse sine of that side. And that undoes that, and they're gone, and now theta equals that. Have you seen that on your calculator, inverse sine? I think you have. Try, grab your calculator. Type in inverse sine of 3/5. Yeah, I pimped that one out. Here, it's even got a tilt deal on it, so you know, like go. Once it comes out, you can tilt this thing like this. Now this actually hooks in. There's a little spot that it'll hook in back there. Okay. Yeah, okay. I was helping somebody with a new calculator that I have in the classroom to borrow. Okay, anyway. If you do inverse sine of 3/5, you'll get some decimal, and it'll be the degrees. It'll tell me what theta is. How many degrees was it? 36, approximately. I think you rounded, and that's fine. So if it's about 36 degrees, if this is 36, can I tell what that is automatically without having to do some big calculation? Yeah, because they have to add up to 90, or a total of 180 for this, this, and this, these three together. But this one's already 90, so then these two have to add to 90. So you can know that it must be 60, 50, 4? 54 degrees. Okay. All right, now, you could see again how that could be kind of handy if you had a real world problem. You knew the lengths of the sides of this ramp were 3, 4, and 5. And you wanted to figure out how big the angle is. Okay, use trig. All right, so back to a typical problem today, though, only gives you 2 sides, like this. And then it says, we want you to calculate all of these functions for that triangle. And it doesn't even tell you that much. It gives you a blank triangle and says that the tangent of this angle is 3/4. And you're supposed to figure everything out from there. Well, the first thing I recommend when you get a problem like this is that you say to yourself, all right, if the tangent of theta is 3/4, then tangent is opposite over adjacent. So the 3 is the opposite side, and the 4 is the adjacent side. And then can you figure that one out? Yes, you can. It's Obama's theme. Yes, you can. So, how do I figure that out? Yeah, well, I know it's 5 because we had this up there before, but how do I figure it out? A squared plus B squared equals C squared. All right, so 3 squared, 9, plus 4 squared, 16 equals C squared. 25 equals C squared. Square root of both sides. Technically, it should be plus and minus 5. But why do I only pick the positive one? Because in the real world, you can't have a side that's negative on a triangle. So I'm throwing that out as a what do you call that? Extraneous answer. So anyway, bottom line, the answer is 5. Now, if you just know the answer is 5, great. But there's going to be something you don't know. Like if I change this to a 3 and then a 7, you won't know what this is. I don't know what that is, but I can figure it out. So that's what I'm going to do right now. I want you to sketch that little triangle there, 3 and 7, and then use a squared plus b squared equals c squared to tell you what the answer is. And it'll have a square root in it, and that's okay. Like, try this right now. You'll use a calculator, you use your brain, you use your pencil, you use your paper. So, Ms. G, tell me what formula I'm supposed to be using. And since I've given you A and B, you know that they are 3 squared is plus 49 equals just C squared. See, I'm just finishing this down. All right, so now I know 49 plus 9 is 58 C squared. Finish it off. Square root of 58. Raise your hand if you knew that. Okay, good. All right, got to be able to handle that. And precalc gets a lot harder than that. That was 7th grade. Okay, so now if I take the square root of 58, from now on when I'm doing my sine, cosine, and tangent, I can use that. So if I want to go back up to sine, sine is opposite of hypotenuse, right? Sometimes I put these little helper letters in here. They really do help. Kind of like the helper monkey on The Simpsons. If you've ever seen that episode, one of my favorites. So these little helper letters will help you to put in the right thing. And they're fine to have in there. They won't hurt a bit. Sine theta is opposite of this, is 3. Hypotenuse from this triangle is square root of 58. And now the cosecant one is the easiest. You just have to flip them. See? And then cosine. What's cosine? Come on, you can do this. So katoa. Cosine is... There you go. And then what is the adjacent one on this triangle? From this angle's perspective, which one's adjacent? Yes. Over the hypotenuse? Square root of 58, and that's the answer. 7 over square root of 58. Good. Then the secant, you just flip it over. Sorry, my cell phone is trying to talk to my... Actually, it's trying to get information from the internet. And then when it's right next to the receiver, it sounds like that. Okay, the secant, you just flip it over, square root of 58 over 7. And the last one's cotangent, flip it over from the 3/7, you flip it to 7/3. Do you get how to do that? All right, here's another problem from start to finish. Let's say it's sine this time. Sine is opposite over hypotenuse. Let's say this is 1 over the square root of 2. You should be able to fill out the rest of that. Do it rapido. Yes? Do it in that same form. I would always write my problem answers in the same format, where you have sine, cosine, tangent, and then cosecant, secant, totangent. Do the answers in that order, because then, I don't know, just you make less mistakes. You should leave them that way. That way they are sides. So the opposite, remember sine is opposite over hypotenuse, right? So I'm telling you that the opposite side is 1. See how that's opposite from there? And I'm telling you by telling you this that the hypotenuse is the square root of 2. And I bet a lot of smart kids have already figured out what that one's got to be. 1, you are correct. Remember that one? 1, 1, and the square root of 2? If you didn't know that one off the top of your head, you'd have had to go this squared, call it a squared, plus b squared equals c squared, and I'd have to stick in a 1 for the a squared plus, I don't know, squared, and a square root of 2 squared, and that makes 2. 1 squared is 1 plus b squared equals 2, and then subtract 1 from both sides. B squared equals 1. Square root of that, b equals 1. So there we go. That's the long proof that that's really a 1. Okay, fill it out. Yes, ma'am.
Is there a reason we would want to get or secant back from your sine?
This is just you getting used to what cosecant is. But here's an example of when you might use it in real life. Real life, you're mostly going to use sine, cosine, and tangent. But cosecant, secant, and cotangent come up in the more advanced trig problems, which is more like calculus. And the calculus that you use as an engineer is based on this kind of stuff. So again, this is getting a little more remote in how you can use it in real life. I'll give you a real life situation. You're probably going to take the SAT or the ACT, and they'll have the stuff on it. And it's really simple if you know what's going on. If they ask you, if they say cosecant of this is, well, what would it be? Square root of 2 over 1. What is tangent? And before today, you probably would have had no idea. And you'll understand in a second here. So once you've got this, you could set up your little triangle and say, okay, well, I know then that you're telling me that the hypotenuse over the opposite is this. So now I can make my whole triangle, figure out the third side of it, and then I just, once I got my triangle drawn, I could have answered any question. Cosine, adjacent over hypotenuse. Wait a minute. Ka. That's adjacent. Yep. Okay. Did I do something wrong in the first place? Opposite.
Well, because the opposite and adjacent.
Oh, that's right. The opposite and adjacent are the same. So I was like, how can this be the same thing? It's because the opposite and the adjacent are the same. Thank you. I was having a crisis moment there. Okay, tangent. Tangent is opposite over adjacent. From this angle's perspective, opposite's here, adjacent's here, so it's 1 over 1. So it's equal to 1. So if they gave you this question and said, this is given, what is tangent? You'd be able to say, oh, tangent is 1. That would have been one of the, it could be an SAT question. Don't expect you to be good at these yet. I just taught you 5 seconds ago. All right, but main things I want you to take from this is that all of these are just the flip. So this is square root of 2 over 1. And this is just a flip of 1, which is 1. And that you can get the third side in a right triangle if you're given, like for instance this, you should be able to find, oh, you've told me 2 sides. You've told me the opposite and the hypotenuse. The opposite here, 3, the hypotenuse here, 7. You can figure out that side using quadratic versus using a squared, b squared, and c squared. And then you could fill out the whole rest of this thing. You could also have figured out how many degrees that is. Remember we did that at the beginning of class? How do you get rid of the sine thing there to get theta alone? You're thinking about changing it to radians. I'm saying I want to solve this, get theta alone. How do I get rid of sine? The inverse sine. I take the inverse sine of both sides. And that tells me how many degrees it is. Okay? So that's what you've learned for today. One other thing, there are some problems on this other one that are, there's a lot of these kind of problems. Okay, they had a wheel, and then they say the diameter of the wheel. Okay, so picture this being a bike. All right, I just saw this cool article on bikes that are for commuters, and they have these bikes that fold up to be really small. And you can just like unfold this bike out of like it's just a tiny little frame, and it's big enough to actually ride, so that you can like ride to the bus stop and then take the bus, you know, like 30 miles into your job, and then when the bus drops you off, a lot of times it's like a half mile to your workplace again. A lot of people don't ride the bus because of that, because it's like a mile to get to the bus stop, and then when the bus stop lets off, it's like a mile to get to their work, and they don't want to walk so much. So they have these little mini bikes you can carry around. Okay, so let's say that the diameter on the wheel is like 15 inches. All right. Well, then here's a typical problem. If the diameter on the wheel is 15 inches, how many times will it go around if you're going to ride 1 mile? And here's what it really comes down to. If you want to get this 15-inch thing to be a fraction, and you're going to change it into, make it 1 mile, don't you really just need to know, I dotted my one, don't you just really need to know what the circumference is? All right, so let's do one kind of like this. I'd like you to start with, take this, figure out the circumference of my wheel. You should know that formula. I told you at the beginning of the unit. You got to memorize the formula. C equals pi d, in case you forgot it already. So then you get pi times d, and what is it? What's the circumference of this thing? 7? Oh, okay, that makes more sense. 47.12 inches. All right, so this wheel goes around once. It's gone around 47.2 inches. How do I change that into, well, think of it this way. 1 mile would be how many sets of these? Well, I don't know how many inches are in a mile, but could I figure it out? Okay, so if I want to change miles to inches, I'm going to multiply by my 1 mile, multiply it by mile on the bottom, so it'll cancel. 1 mile is how many feet? 5,280. And now I got my answer in feet. And now if I want to get that feet into inches, times it, go ahead. 12 inches, 1 foot. You got it. Now my feet have canceled. Now I got my answer in inches. That's how many inches there are in a mile. And I just take that and divide by 47. All right, here's another typical problem that they might give you on this. Let's say that the guy is riding his bike at about 20 miles an hour. That's pretty fast, but you can do that. Okay? So let's say he's riding his bike at 20 miles an hour. Oh crap, I just erased it. I'm going to see if I can undo that. I'm going to need that circumference. There we go. Please change 20 miles per hour. Miles per hour, miles on top, hours on the bottom, into how many times is the wheel going around? Which is rotations per minute. So if you're riding this bike at 20 miles an hour, how many times is that wheel going around each minute? A lot of times. So I got to multiply by a bunch of stuff. First you should be thinking miles. I got to get rid of miles because eventually I want my answer in rotations. What's a fact we know about miles that's going to get us closer to the inches thing? 5,280 feet in 1 mile. Okay, now my miles is gone. Now I got feet per hour. It's not even close. But I got to get my feet out of there. I know that, so I put feet down here. What do I know about a foot that's going to help? 12 inches. Now my feet can cancel. Now I got inches per hour. I'm getting closer. Because inches, now I can change inches to rotations, right? So then I go inches down here, so it cancels. And then, what do I know about inches and rotations? 1 rotation, say it. Yes, 1 rotation's 47.12 inches. Now my inches are canceled. Now I got rotations per hour. I'm so close. I just got to change my hours to minutes. Yes. 1 hour. Hold on, let me finish it. 60 minutes. That made my hour canceled, and now I'm down to rotations per minute. Yes. Could I make it rotations per second? Yep, I could just do one more little factor in there. Get the idea? You just keep on making little factors, and each factor cancels out something, and it's got to be a fact that you know is true. Like 1 rotation is 47 inches, or 1 hour is 60 minutes, or 12 inches is 1 foot, or 5,280 feet in 1 mile. These are all things that you'd be expected to know. In other words, you better memorize that there's 12 inches in a foot. I obviously expect you to know that, and I expect you to know this one, 5,280 there, feet in a mile. Okay, so that's a review of yesterday's stuff. Today's stuff is just that stuff with the new functions. Instead of just sine, cosine, and tangent, now I got cosecant, secant, and cotangent. That's all I got for you for today. Oh, just in case you're wondering, the assignment that goes with this is, if you're following along at home, is page 366, 1 through 7 odd. Ooh, that's tough. And then 9 through 28 all. That's the meat of the assignment. Okay.